Okay, to continue class, so we have the same reaction. This is rusting of iron. In this case, you have a certain amount of the two reactants. So if you have 200 grams of iron, so you have here, for the given, you have 200 grams of iron that will combine with 100 grams of oxygen. So we have two reactants and you are going to determine the first question, which of the two reactants, iron and oxygen, is the limiting reagent and the excess reagent. And take note that for every chemical reactions, it is always the limiting reagent that determines the basis on the amount of the product that will be produced. Okay, so it is good for every reaction that we must be able to know which one is the limiting reagent so that you would be able to theoretically compute the amount of the product that will be produced, because that will be based on the limiting reagent. Now the question is, how are we going to determine which of the two reactants is the limiting reagent and the excess reagent? Now the ones that we have here, we have the ratio between iron and oxygen. This is standard, theoretically based on the equation that you have 4 moles of iron needs 3 moles of oxygen. That is exact. So based from the balance equation, we cannot have the excess and the limiting reagent. But in reality, once you have a certain amount, like you have 200 grams of iron and 100 grams of oxygen, which one here is the limiting reagent and the excess reagent? So there are two ways actually on how to determine the limiting and excess reagent. One way is you can just convert this one, the 200 grams of iron, 2 moles of iron, and compute for the amount of oxygen needed by that certain moles of iron to completely react. And vice versa, 100 grams of oxygen, convert this one to moles and compute for the amount of iron in moles needed to react with that certain amount of oxygen. Or you can have it in terms of grams, because the given is in grams, so that you would be able to visualize. No? So which one is in excess, which one is limited. So if you have 200 grams of iron, this one, 200 grams of iron, how many grams of oxygen really is needed? No? That is why our unknown here is grams oxygen. That is because if you have 200 grams of iron, how many grams of oxygen really is needed or reacted by the 200 grams of iron? So basing on the stoichiometric that we have, so you have grams of iron, you convert this one to moles of iron, and using the molar mass, then convert moles of iron to moles of oxygen. Okay, moles of oxygen, then moles of oxygen to grams of oxygen. So from here, you can compute that for every 200 grams of iron, it will react only with 85.71 grams of oxygen. So this amount of oxygen, 85.71 grams, is the amount needed to react with 200 grams of iron. So therefore, if you are going to base it here in the given, we have 100 grams of oxygen available. But what is needed only by the 200 grams iron is only 85.74. So meaning, the 100 grams here oxygen is in excess. Okay, so because the 200 grams of iron needs only 85.71 grams of oxygen to react to form ferric oxide. Okay, so with this equation, with this computation alone, you would be able to determine now that the oxygen here, oxygen is the excess amount, because what is needed only is 85 grams while what is available is 100 grams. So therefore, oxygen is the exist reagent and iron will be the limiting reagent. Or if you want to verify, then you can compute also the amount of grams of iron needed if you have 100 grams of oxygen. So if you have 100 grams of oxygen, you have your 100 grams of oxygen, how many grams of iron is needed to react it completely? So again, basing on the stoichiometric relationship and the steps, so grams of oxygen will be converted to moles oxygen. Then moles oxygen, convert it to moles iron based on the balance equation. And from the moles of iron, convert it to grams of iron, okay, using the molar mass. And it is 233 grams of iron. So if you have 100 grams of oxygen, it needs 233.33 grams of iron. So therefore, since there is only 200 grams of iron available, then if all of the 100 grams of oxygen will be consumed, it needs 233.33. So therefore, iron is limited. Okay, so basing on this computation, you would be able to know that iron is the limiting reagent and oxygen is the exist reagent. Okay? Or you can have also the other method, you have or here, or you can compute the amount of the product. Okay, the amount of the product, amount of ferric oxide that will be produced separately by the 200 grams of iron and 100 grams of oxygen. So whichever will give the smaller amount of the product, that is the limiting reagent. So if you consider first the 200 grams iron to determine the amount of the product, which is ferric oxide, so 200 grams iron, change it to moles of iron, then change it to moles of ferric oxide, then change it to grams ferric oxide. Okay? So again, do not forget, if you are going to change it from moles to grams of the same substance, use the molar mass. If you are going to change it moles of one substance to another substance, use the balance equation. Okay, so basing on this one, 200 grams of iron, it will produce 285.71 grams of ferric oxide. Okay, that's one. So again, the ferric oxide, 285, will be produced from 200 grams of iron. Okay. Next is the oxygen as reactant. So how many grams of ferric oxide will be produced if all of the 100 grams of oxygen will be consumed? So again, based on the steps, grams oxygen, change it to moles of oxygen. Then from moles oxygen, change it to moles ferric oxide. Then from moles ferric oxide, change it to grams ferric oxide. And the amount of ferric oxide that will be produced is 333.33 grams of ferric oxide. So this amount is based on oxygen. So this one is based on oxygen. This one is based on iron. So whichever gives the smaller amount of the product is the limiting reagent. So you can, it is verified that from here, same answer, and from here, same answer. So therefore, you may conclude now that the limiting reagent, take note when we talk of limiting and exist reagent, it will be based on either of the reactants. So the limiting reagent now is the iron, and the exist reagent is oxygen. Oxygen, take note O2. So this will be this is the answer for question number 1. Now for question number 2, how many grams of rust form. So that is now the product. So the amount of rust that is in grams, that is how many grams. So the grams of the product form, which is the rust, the taya, ferric oxide, is, you can base it from here. So take note that the amount of the product form is based on the limiting reagent. Now, since iron is the limiting reagent, so therefore the computation basing on the 200 grams of iron, which is 285.71 grams of the product, will be the amount that is being produced. So therefore, grams of iron produced is 285.71 or 714 grams of ferric oxide. Okay, since that is the smaller amount. So that's the answer for question number 2. For question number 3, the question is, how much is the exist reactant? Take note that the exist reactant is oxygen, exist. Now the question is, how much is in exist? How much is not reacted, unreacted? So you can actually compute here. So the exist, or the grams of, you can have grams of oxygen, since oxygen is the exist reagent, grams of oxygen exist or in exist will be whatever is available. Since the available is 100 grams oxygen, you determine for 200 grams of iron, how many grams of oxygen really reacted from 200 grams of iron. And we have computed it already from here that if you have 200 grams of iron, it will react only with the amount of 85.71 grams of oxygen. So therefore, this amount, the 85.71, this is the oxygen, amount of oxygen reacted with the 200 grams of iron. Okay, 200 grams of iron, 85. Since the available amount of oxygen is 100 grams minus the amount of oxygen reacted, which is 85.71 grams. So the difference is the exist amount. So you just get the difference. So we have 100 minus 85.71. So the exist amount is 14. We can round it off up to 2 decimal places. 14.29 grams of oxygen. So this is the exist amount of oxygen. Okay? And this is the amount of the product produced. Okay, study the video, and if you have question, ask it next meeting.